Okay, I think I restarted. restarted this video. So this is for a couple of students who have asked me about making up the classwork homework assignment on standard deviation and the normal curve. And the idea, there's two problems you have to do. There's an example problem, and then there's a problem you do on your own. And you really need to see the first problem done out in order to be able to do the second problem. So this video is going to take you through the first of the two problems. You should just be able to copy down what I'm doing. And then the other problem is the same set of skills. It's just different numbers. So for the first one, it says create histograms for the following data sets, then describe them as negatively skewed, positively skewed, or normally distributed. So both of these data sets, we would count by ones, okay? So I'll try to do an example of like one that's different because one of the ones on the classwork is different. So a histogram is pretty much just a bar graph. This is what made me mess this up earlier. Let's see if I can get it right. So it's essentially a bar graph, and the numbers in data set 1 go from 2 to 7. So you might go from like 1 to 10, you know, but really you just need the 2 to the 7. So we'll go 2, 3, 4, 5, 6, 7. And then I'm going to use X's because they're easy, but you can use dots, you can use bars, which is probably what you're familiar with, just using like a bar. But there are 2 2s, there are 2 3s, there are 2 4s, there are 3 5s, there are 1, 2, 3, 4 6s, and 3 7s. And what you want to notice about this is how the data is distributed. So it's not evenly distributed, it's not symmetrically distributed. When you draw like a little curve over it, the curve looks like that. So that's kind of what we mean when we talk about the skew or the distribution of the data. This always kind of messes with me because I always want to look at the lump, and you don't look at the lump, you look at the tail. So the tail of this data, like kind of the direction of the taper is towards the negative numbers. It's like pointing towards the negative. And so this particular one is what we call a negative skew. Okay, and you can find that in your notes. So you might need to go back and look at the notes for this lesson, but there's like a little, actually I can probably, got one here. It looks like this, and it should be on the bottom of one of the sets of notes, and it gives you a little description, and you can tell that we're looking at one that's got like the tail. It's this one where the tail is going. Hopefully this isn't flipped around backwards. A little concerned. I think it looks on my end like it's flipped, like my left and right are switched. So but look it up. So this is a negative skew. And again, what you're looking for is that distribution, like how are they distributed? Let's go ahead and do the other one. Now the other one goes from 5 to 9. So 5, 6, 7, 8, 9. And we have 2 5s, we have 3 6s, we have 1, 2, 3, 4, I think it's 5 7s. 3 8s, and 2 9s. And what you want to see about that is that it is that like symmetrical distribution. So that is the normal distribution. So the normal, you've got like the mean and the median are the same number, and the mode, like they should all be the same number, which they're not always the same number, but in a normal distribution they are. And it's like that peak, and then it goes off symmetrically on either side. So that would be a normal distribution. Now, just so you know, if you look down at your worksheet, if you look at the, I think it's like says homework. That's a club meeting outside my room, so sorry if you can hear all that. But if you had numbers that were like, say, a little bit different, so you had like 22, 24, 26, 36, 37, 48, 49, okay, something like that, you wouldn't want to count by ones, because there's just way too much spread. Like nobody wants to count from 22 all the way up to 49. That's gonna like it's way too long. So what you would do in that case, and if you look at your data set, you would count by tens. Okay, in that case. So your number line might look like this, where you have like 20, 30, and then 40. And then everything that was in the 20s would get lumped like over the 20s. Everything that was in the 30s would get lumped in the 30s. Everything that was in the 40s. And you can pick whatever you want for your scale. So you can count by ones, you can count by fives, you can count by tens, you can count by hundreds. The purpose of the histogram is to show how the data is spread out. So if you pick a range that's like too narrow, what will happen is like, or I guess like what you call like you make your bins too big, but that vocab doesn't mean anything to you. All your data points will stack up in one column or like maybe two columns, and you just won't see what you need to see. If you count by two like little intervals or your bins are too small, you end up with like one data point in each column, and again you don't see what you need to see. So there's a little bit of an art to it, kind of looking at your data and saying, okay, I want to count by ones, or I want to count by tens, or but in your classwork or homework, whatever the other problem is, one of them you're going to count like we did here. So you're going to count by ones, and the other one you want to do what I did in this little thing here, and you're going to count by tens. Okay. So, and I think if you look at the class notes for that, we did some histograms in the class notes. This is a blank copy, but you should have one that's filled in, or you can go to the video and fill it in. But we counted by tens, so that'll give you an idea what to do. So the first part is do the histograms and then identify the skew. The second part is question 2. So it says, suppose a standardized test is given. The average score is 500 with a standard deviation of 50. Now, if you read yours, like the one that you have to do on your own, yours is different. You have a different average score and a different standard deviation. So the first thing you are asked to do is to draw the normal curve and label the scores for plus or minus. Now, again, I want to go over that vocabulary. Plus or minus 1 standard deviation. So that little symbol there is a lowercase sigma. It represents the standard deviation, which in this case is 50. And plus or minus means you're going to go in the positive direction and also in the negative direction. So let me go and do this. So it says draw the normal curve. So there's my number line, and there's my normal curve. The average is going to go smack dab in the middle. Okay, now it's 500 for this one, but yours will have a different number. You're going to turn them both in, so you need to be copying this down too, just so we're clear. And then you could go to the right. That's the positive direction, so that's positive 1 standard deviation. And pretty much you just say, okay, well, what's the standard deviation? Standard deviation is 50, so 500 plus 50 means that that is at the 550. Then we'll come over here. So this would be plus 2 standard deviations, so we'd add another 50. So that's going to bring us to 600. And then we have this third one. And so you keep adding 50. And then we can go in the other direction. So we can subtract 1 standard deviation. I don't know if you can see, like when I'm pausing, there's like a thing popping up on my screen. So we would do 500 minus 50, which is 450. And then we would subtract another standard deviation. So subtract another 50. And then subtract another standard deviation. Okay, now just so you get used to some of the vocabulary, and if you're doing this before the EOC, that's, I guess, kind of nice. But the way we would talk about this is we would say 600 is 2 standard deviations above the average. So somebody could ask you a question like, what score is 1 standard deviation below the average? 1 standard deviation below, that's going to be 450. So the answer would be 450. So you've got the scores, and then this curve represents the percentage of people who score in that band. So if you know that it is normal then these numbers are always the same. So, So this is 34%. This is 34%. And here's what that means, just to interpret that. What that means is that on this particular test, because we're talking about a test, 34% of the people who took the test scored between 500 and 550. So, and then 34% scored between 450 and 500. 68% of the people who took that test scored between 450 and 550. And so you'll see that another way you might hear that is 68% of people scored within one standard deviation of the average. So one standard deviation in either direction, 68% of the people scored within that band. In fact, a lot of times you'll see this done with like one arrow and it'll say 68, like between the two. Now, I don't know if I have enough space to write like all the percent signs, but these are all percents. So this is 13.5%. And those, all four of those added together give you a 95. This is 2.35%, and this is another 2.35%. And then the last one, whatever's left over, and it actually does go on forever. You can keep breaking it down, but it ends up, like, it starts to be like really, really small. So, now, those percentages are always the same. So what happens a lot of times in class is students are like, where did you get those numbers from? They're always the same. If you know that it is a normal curve, okay? Like, so if you are told that it is a normal distribution or these are distributed normally, then those are the percentages all the time. The reason I know them is because I write them over and over and over again. I teach multiple sections of Algebra 2. I keep going over it. I keep repeating it. I'm saying it out loud. I'm writing it down. So I remember it. And the same is true for you. Okay, so you're going to just keep writing it down and remember it. Once you have that, then answering the questions, which is the next part here, becomes really, really, really easy. So very straightforward. What score is 2 standard deviations below the average? So here's the average. Here's 1 standard deviation below. Here's the 2nd standard deviation below. So 2 standard deviations below, the score is a 400. And it's like literally that easy. And you can just change that question up. So it could be 1 standard deviation below, 2 standard deviations above, 3 standard deviations below. Like, it's, you could even do like a half a standard deviation. So you would just go like halfway and like what would be there. Next question, what percentage of people scored above a 650? So above a 650, here's your 650 over here. And we want to know what percentage of people scored above. Well, remember I said all of those were percents. So that is 0.15% of people scored above a 650. The next one is what percentage of people scored between 450 and 600. So there's the 450, there's the 600. And the question was, what percent of people scored between? It's a lot of people. You can tell it's a lot of people because I'm shading in a lot of that curve. But to get the answer, what you would want to do is add up those individual percentages. So we would have 34 plus 34, which is 68, plus the 13.5. So that's 81.5%. So 81.5% for the third one. And then the last question is, what is the z-score for a person scoring a 425? So there's actually 2 ways that you can figure out what the z-score is. One of them is, I think it's kind of fun. You locate the score on the number line. So 425 is right here. Okay, it's exactly halfway between 400 and 450. So sometimes numbers can do that. Sometimes like they're not as nice, like you can't really tell, but this one you can. And remember what z-score is. Z-score is the number of standard deviations above or below the average. So 425 is below, which means that the z-score is negative because you're going below the average. How many standard deviations did I go below? I went 1 standard deviation below and then a half a standard deviation. So if the z-score is the number of standard deviations above or below, then in this case, the z-score would be negative 1.5. Okay, so you can actually get it like that, negative 1.5, but usually that's not how you're going to do it. So, but just kind of remember that number. All right. So yeah, the way that you're probably like expected to do it, there is a formula, and I gave it to you like this. Not like that. Don't write that down. That's wrong. It is the number minus the average divided by the standard deviation. Now, that if that doesn't look really sophisticated, it's because it's not. Okay, so typically you would see it like this, I think, on your reference sheet. It's X, they use an X instead of a number. They use that funny little symbol. And then standard deviation was that sigma. That funny little symbol that I did, that's called a mu. It's the Greek letter mu, M-U, and it looks a little bit like an M and a little bit like a U, so that makes it easy to remember. M-U, mu. It's like the sound a kitten makes. Mew. I don't have a voice. Okay, and so you can calculate z-score using this formula. This version is probably just a little bit easier to get your head around because that's a new symbol for you for average, and you'll be like, what is that? So we'll go ahead and we'll use this. So it's the number in question, which in this case is 425. So we're going to do 425 minus the average, which in this problem was 500. And that's where the negative comes from, okay, because the average was bigger. And the standard deviation was 50. Make sure that when you're doing yours that you plug in the right numbers. You don't revert back to doing this one. 425 minus 500 is negative 75. And negative 75 divided by 50 is negative 1.5, which is what we got when we looked at it this way. So negative 1 and then the extra half. Okay, so hopefully that helps. It's a little shorter than 20-minute video. I wanted to get that done. I had like a window of time to get it done. So what you need to do if you're going to make this up is you need to copy all of this down, because this is like the free part. This is like the free half of the points, just copying this down. And then you want to take what you learned from doing this and basically replicate it on your own in another problem, and you turn both of them in. Please fill out the late work form. And I don't know what you'll check off on the box, but put a little thing in there saying I was absent, but I'm making this up. And there's no late makeup window on it. So I guess you can check absent within the window and just say, hey, you didn't put a window on this. So I'm doing it. Okay. Let me know if you have any questions, and I hope this video helps.